Hello everyone. Welcome to the first lecture in statistics. In this lecture, we will introduce the topic of statistics. We'll try to define what statistics is, talk about what is involved in a statistical study, and we will introduce certain terminologies which we will be using over and over again through the different lectures in statistics. This is a list of what we'll cover in this lecture. We'll first try to understand what statistics is and what is involved in its study. We will talk about the two different types of statistics, and then these are some of the terminologies that we will try to define what a population is, what a sample is, and then we'll define a parameter versus a statistic. And because statistics is all about data, we will briefly talk about the different types of data that we will deal with and how to recognize the data types, right? Now, what is statistics? Statistics is the science and art of working with data. Now, all around us, every minute, we are surrounded by different types of data. Data can come to us in the form of names, data can come to us in the form of numbers, data can come to us in the form of pictures, graphics, videos. Data is surrounding us all the time, everywhere. All right? And we want to make some use of that data. What statistics does is statistics analyzes that data that is around us by gathering it, by collecting it. They analyze it and then they use that to make some predictions, to draw some conclusions from, so that we can harness that data and use it effectively to improve our lives. So that's the role of statistics. All right. So let's read the definition as given here. It says statistics is the science of collecting data, because first we have to gather the data. We have data surrounding us all the time, but we need to put our hands around it. We have to collect that data, and data can be numerical or non-numerical, does not always have to be numbers, because whenever we think of data, we always think it's numbers, right? No, data can be anything. It can be numbers, it can be names, it can be words, uh, uh, it can be pictures, right? It can be videos, it can be sounds, it can be come to us in various forms, right? But we have to first collect that data, and then once we collect that data, we have to organize that data, we have to summarize it, and then we have to take measurements on it if we can, right? We have to, in order to analyze that data, we have to organize, summarize, and draw or make some measurements on that data to be able to understand it, to make it manageable. And then once we have summarized it and taken the measurements, we will use it to draw some inferences. We will analyze it to come to some conclusions and also perhaps to predict the future, all right, by looking at the pattern of data. So that's what statistics is all about, right? Now, there are two parts of statistics. There are two types of statistics. One is called descriptive statistics and the other one is called inferential statistics. What happens in descriptive statistics is we gather our data, and then once we gather the data, now that data that we gather is not futuristic data, it is actual data, it is past data. All right, something that has already happened, and we collect that data, and then because data is vast, data is random, data is disorganized. We cannot make much sense unless we organize it, we summarize it, perhaps tabulate it, and then start taking measurements. So all the work that we do on past data that we have gathered from somewhere is known as descriptive data. All right, it consists of methods for organizing and summarizing information as well as taking measurements. And maybe I should add here a phrase which says on past data, on past uh, collected actual data, on past collected and actual data, something that is real, something that has already happened. Inferential statistics, on the other hand, consists of methods for drawing and measuring the reliability of conclusions about a population based on information drawn from a sample of the population. Now, what this means is, for an inferential study, we will be drawing some conclusions, all right, coming to some understanding of how the universe works, the greater universe works, uh, and if we can make a prediction for the future using the past data. That's all a part of inferential studies. So there's descriptive study involved in statistics as well as inferential study. Now, there are two key words here in red. It's called population and sample. So unless we understand the difference between population and sample, it the word inferential will not be exactly defined properly. All right. So let's go into understanding what a population is versus what a sample is. Now let's try to understand what a population is versus what a sample is. Now, previously, when we were talking about inferential studies, we said that in inferential studies, we try to draw conclusions or make inferences on the population based on a sample study. All right. Now, the population represents the subject that we are trying to study. All right. So let's read what it says here. It says the population is the collection of all individuals or items under consideration in a statistical study. Now, when we decide to perform a statistical study, we of course first have to come up with a topic for the study. We have to define our study. All right. So the first step is to define your statistical study. Define the study. And based on what you are studying, you will need to define a population. All right, define a population on whom you are performing the study. Okay, who is the subject of your study, or what is the subject of your study? It need not always be people that you're studying. You could be studying plants, you could be studying cars, you can study inanimate objects as well as animate objects, all right, living or non-living things. Everything can be studied in a statistical exercise. All right. So we have to define our study, and then based on what our study is about, we have to define a population. So let's say our study is to find out the average height of 10-year-old boys. 10-year-old boys. All right. In the US. I'm going to be more specific. So we are talking about studying the average height of 10-year-old boys in the US. What is our population if that is our study? It's going to be all 10-year-old boys in the US, all right? The population is going to be all 10-year-old boys in the US. That's our population. But imagine how many 10-year-old boys there are in the US. There must be several millions, right? All over the country. If you were to perform a study on all 10-year-old boys in the US, we would all go crazy. All right? It's not possible. It's millions of the population size of 10-year-old boys is probably several millions. It's not possible to gather data so easily from million boys. Many families wouldn't even want to disclose or have their kids participate in your statistical study. It's time consuming, it's not practical, it's also very expensive to perform a statistical study on the entire population. So what we do is we take a subset of the population, and create what is called a sample. All right, we create a sample and we get the data, whatever data we need on the height or weight or whatever we may be studying. We get our data from the sample. So what is a sample? Sample is a subset of the population that we are interested in studying. So here it says the sample is a part of the population, or you can say the subset of the population from which information or data is obtained. So we create our sample and then we organize that. We get the data, we obtain the data from our sample, take their measurements, and once we gather the data, we organize it, we tabulate it, and do all the descriptive studies. We take measurements on it, and then once we are ready, when we are done with our descriptive study on the sample, we will then use it to draw some conclusions about the heights of all 10-year-old boys in the US. All right. So that's how statistical studies are done. Statistical studies are rarely done on the entire population. It is done on a small sample which is representative of the population, and we perform the descriptive study on the sample and then project it on the population, which becomes the inferential part of statistics. All right, when we take our sample measurements and try to determine if that would be true for the entire population or not, that would become your inferential studies. All right, inferential part of statistics. Now, associated with the terms population and sample that we just talked about are two other terms which are called parameters and statistic. A parameter is a descriptive measure for a population. When we take any measurements on the population, let's say it is possible to do a certain study on the entire population. Maybe our population size is not that big, it is manageable, and we decide to gather our data from the entire population instead of drawing a sample, and we take measurements on that data obtained directly from the entire population. Those measurements are referred to as a parameter, right? PP, you can align it that way. Any measurements taken or obtained from the population is referred to as a parameter. Any measurements taken from a sample or any measurements obtained from a sample is referred to as a statistic, right? Now, since statistics is all about working with data, we need to know the different types of data available out, right? The first thing is a variable. What is a variable? A variable is a characteristic that varies from person to another, from one person to another. It need not be person. It can be some inanimate object as well. All right. So a variable represents whatever you are trying to study. For example, when I said that we would like to study the height of 10-year-old boys in the country. Height is what we are trying to study, correct? Height represents a characteristic that we are studying. That is a variable. All right. In that case, the variable is the height, the characteristic. If we are trying to measure the weight, if you are trying to study the weight of an average woman in this country of a certain age group, maybe of uh, 20 to 30-year-old women in this country, then weight is going to be the variable. All right. What is data? Data is a specific value of a variable. So when we go and start collecting the measurements or the heights of different boys and 10-year-old boys, right? That specific value that we collect for that variable height is referred to as a data, right? So the variable does not have a value. The variable, once the variable has a value, that value is referred to as data, all right? And then there are two types of data that we will be studying in this course. It's called the qualitative data and the quantitative data, and we will go into more detail in a future section of the chapter. But data types are of two types, qualitative and quantitative. Qualitative is non-numerical data, all right, data that does not come to us in the form of numbers. And quantity, all right, quantitative comes from the word quantity. It refers to numerical data, data that comes to us in the form of numbers. So height, for example, is a quantitative data. But if I ask you what is your favorite car, all right, then your answer to me will not be a number, it will be the name of a car, correct? It could be a Toyota or a Honda or a Nissan or a Mercedes or a Ferrari, whatever your favorite car is. But that data, it's still a data, even though it's a name, it's still a data, but it falls under the qualitative or categorical type of data. Whereas um, quantitative data could be people's heights, people weight, people's age, right? Or the amount of rainfall, the amount of snowfall, all those are numerical forms of data. They are called quantitative data. All right. So qualitative data is also known as categorical data. It's non-numerical, usually expressed in words rather than numerical numbers. For example, the name of a book, the color, what's your favorite color, your blood group. These are all non-numerical data, also called categorical data. And quantitative data is data that is countable or measurable and expressed as whole numbers or decimal numbers. Countable quantitative data is called discrete quantitative data, and measurable data is called continuous data. So we will go into more detail on the different types of quantitative data and how to do the studies based on the data type. Now, so far we said data or we talked about data that comes to us in the form of names or comes to us in the form of numbers, but nowadays, especially uh, images. All right, images are also considered data, images, videos, any graphics or sound, any audio data is also considered to be data. All right, so it's not strictly qualitative and quantitative, but there is another completely a different category of data which represents images and which not necessarily names, but uh, it's really images, graphic data. All right. So here we have the data types represented graphically. Data is of two types: qualitative categorical or quantitative numerical, right? This is in the form of names, all right? Data in the form of names comes to us in the form of names, and we have quantitative data comes to us in the form of numbers, and when those numbers are countable numbers, they are called discrete data. All right, discrete numerical data. Countable meaning our age. We count our age, right? 1 year old, 2 year old, 3 year, or number of students in a class. If I ask how many students are in this class, we will count the number of students. We are not going to measure the students, all right? So that would be considered discrete data type. Anything that is countable. How many cars uh, do households have? How many rooms do houses have? All right, those are countable variables. So uh, they are referred to as discrete data type, and measurable data like height, weight, rainfall, snowfall, anything that can be measured is referred to as continuous. And measurable data is very often uh, comes to us in decimal forms, whereas countable data would be integer whole numbers, all right, starting from 0 and above. Let's try to identify some of these variables and categorize them in different data types that we learned. Height is a measurable data, so we will say this is a, continuous, a continuous quantitative, that's numerical data, right? It's numerical, all right, but it's measurable, so it's quantitative data. Age, we count age, therefore it's discrete quantitative, discrete quantitative. Number of siblings, that's countable. We have to count first in order to tell somebody how many siblings there are in a family. So that's also discrete quantitative. What about place of birth? All right. If somebody asks you where were you born, you're going to name a place, right? So that's going to be qualitative. It's a qualitative value. Weight, again, is continuous quantitative because it's measurable and it can be in decimal form. So continuous quantitative. Your gender, the gender is qualitative, male or female, right? So that's qualitative. Religion, again, it's the name of a religion, that's qualitative. And high school rank, it's 1, 2, 3, 4, that's how we rank. So it's going to be discrete, all right? We don't have a rank which is 1.5 or 1.53. So it's discrete quantitative. All right?